this question says, a chemist dissolves 685 milligrams of pure sodium hydroxide in enough water to make up 180 milliliters of solution, and it wants us to calculate the pH of the solution. So the first thing I want to do is look at the equation here. We have KOH, potassium hydroxide, solid, which is a strong base, which will completely dissociate in water to form K plus aqueous plus OH minus aqueous. So KOH dissolves in water to form hydroxide. We can find the POH because this will completely dissociate. POH equals the negative log of the concentration of OH minus. So if we can find the POH, we can then find the pH because POH plus pH equals 14. Said another way, pH equals 14 minus the POH. So we have several jobs. So again, KOH is a strong base. It dissociates into K plus and OH minus. If we can find the concentration of OH minus, we can find the POH, and if we find the POH, we can find the pH. So let's do that. So let's start with 0.685 grams of KOH. And then we want to convert from grams of KOH to moles of KOH. Once we have moles of KOH, we want to convert it to moles of OH minus, because that's what we're actually going to plug in. And some of the strong bases have multiple OHs, so we want to convert to moles of OH minus. This one doesn't, but that's okay. And then we want to divide by the volume in liters of solution to find the molarity. So starting with 0.685 grams of KOH times, we put 1 mole of KOH on the top, and the molar mass, which is 56.11 grams of KOH on the bottom, times each KOH gives us 1 OH minus. So we put 1 mole of KOH on the bottom, 1 mole of OH minus on the top, times, we want to divide by liters, so we put 1 over the volume in liters, divide by 1,000, 0.180 liters. And when we do all that math, we find that the concentration of OH minus is 0.068, it's 0.067823 molar, where that's the sig fig right there. So this is the concentration of OH minus. So we can plug it in here. So it's the negative log of 0.067823. And the POH equals 1.168622. Here we had 3 sig figs, so here we should have 3 sig figs. Note that the 1 doesn't count as a significant figure, as in several other examples. So now to find the pH equals 14 minus 1.168622, where again that's the sig fig. We consider this as essentially sig figless, so we want 3 decimal places here, which is 12.831 for the pH of this solution. There are multiple ways to do this. We could have, for example, converted the concentration of OH minus to a concentration of H3O plus, and then directly plug that in to pH equals the negative log of concentration of H3O plus. However, here, I thought this was probably the easiest way to find the pH of a strong base solution.